In this lecture, I'm going to talk about sinusoids and phasors. Sinusoids and phasors. Okay. What is sinusoid that we know? It's any like a sinusoidal signal in the form of a VA cosine of omega t plus c is a sinusoid. What is the phasor? Phasor is a complex number representing the amplitude and phase angle of a sinusoidal signal. First, we all know that what is a complex number. A complex number is a number which is consists of real part and imaginary part. In some mathematics books, they refer to I, but here we show like a square root of -1 with letter G, with letter J, not I. So, and as I said, phasor is a complex number representing the amplitude and phase angle of a sinusoidal signal. Okay, here we have a sinusoidal signal. V of t is equal to VA cosine of omega t plus c. We know that VA is amplitude, omega is angular frequency, and phi is phase angle. Three important parameters for each sinusoidal signal. So, before talking about the phasor, I want to introduce a very important formula called Euler's formula. What is Euler's formula? This formula says that e to the power of j theta is equal to cosine of theta plus j sine of theta. Okay, and of course e to the power of negative j theta is equal to cosine of theta minus j sine of theta. And also we can say cosine of theta is equal to e to the power of j theta plus e to the power of negative j theta over 2, and sine of theta is equal to e to the power of j theta minus e to the power of negative j theta over 2j. All these four equations are Euler's formula. By the way, we should know that these two equations can be extracted from the first equation. So if we know the first equation, we can easily find the other equations as well. Okay, so uh, as I mentioned, e to the power of j theta is equal to cosine of theta plus j sine of theta. In another way, we can say that cosine of theta is equal to the real part if we consider e to the j theta as a complex number, which is, we can say cosine of theta is the real part of this complex number. If you look to this equation, we see that cosine of theta is the real part of this complex number. In the same way, we can say sine of theta is the imaginary part of e to the j theta. Okay, so we learned all these information so far, the Euler's formula and the relationship between e to the j theta and cosine and sine. Now let's consider a sinusoidal signal and see what we can do using Euler's formula. If we say v of t is equal to va cosine of omega t plus c, is we can say it's equal to va, the real part of e to the power of j omega t plus c. Just remember that I said cosine of theta is equal to the real part of e to the j theta. Now, if we substitute the theta with omega t plus phi, we can say that va cosine of omega t plus phi is equal to va, the real part of this complex number, the real part of e to the power of j omega t plus phi. Okay, now now that we have this relationship, we can say it is equal to va, a real part of, let's separate or like split this term to two terms. We know that e to the power of a plus b is equal to e to the power of a times e to the power of b. Let's apply this rule to this term of our equation. So we can say is equal to va, a real part of e to the j omega t e to the power of j t. Okay, it's equal to, because va is the constant value, we can just bring it inside this bracket. So we say it's equal to va, a real part of va e to the j phi e to the j omega t. Now we reach to this point and we call this term a phasor. So this term of our function is called a phasor. So phasor is va e to the power of j phi. If you look, you see that it is representing the amplitude va and the phase angle of phi. It doesn't like it. It's not included the frequency. It just includes uh, amplitude and angular phase angle. So So we can say phasor is equal to VA e to the power of JV. This kind of representation is called polar representation. Polar representation. We can write it in this way using Euler's formula. VA cosine of B plus J VA sine of B. This type of representation is called rectangular representation. Okay, and of course the polar representation can be shown like in this way, VA with the angle of B. So this one also is polar. Okay, here is the representation of phasor. Now that we learned the phasor equation and we know what is the phasor, let's find the phasor of some signal. Example, let's assume we have this signal V of t is equal to 20 cosine of 150t minus 60 degree, and we want to find phasor. Okay, so we know that the phasor consists of amplitude and phase angle. So we can simply say phasor is equal to 20 with the angle of negative 60. We can also show it with this in this form, 20 e to the negative j 60, or in the rectangular form of 10 minus j 17.3. Okay, let's see. First of all, we should know that this one is a polar representation, this one is a polar, and this one is a rectangular. How did we find these values? It's easy. We know that based on the convention, we know that 20 cosine of negative 60 plus j 20 sine of negative 60. In order to convert it to to polar. So 20 times cosine of negative 60 degrees 10, and 20 sine of negative 60 is negative 70.0. So this one is the way we find the polar and rectangular representation of each complex number. Next example. Convert phasor (169) the angle of negative 45 at frequency of 60 hertz to sinusoid. Okay, the first thing we need to do is finding the frequency. Omega is equal to 2 pi f, which is equal to 2 pi 60, which is equal to 1200 pi. So the angular frequency is 1200 pi. Uh, we know that Vt, the signal, is a real part of Va e to the j phi e to the j omega t. Let's just substitute the values. So it's equal to real part of Va is 169 e to the power of negative j45 e to the power of j 1200 t. 1200, not 1200, 2 pi 60 is 120 pi, not 1200, 120 pi. So e to the power of j 120 pi t. Okay, and now we can say v of t is equal to real part of 169 e to the power of j 120 pi t minus 45, which is equal to 169 cosine of 120 pi t minus 45 degrees. Or if you replace pi with 3.14, we will have the signal is equal to 169 cosine of 377 t minus 45 degrees. Okay, so I believe that we did an extra step here to make it clear. But for the like upcoming examples, we don't need to do and repeat that extra step. And that extra step is here. In fact, we don't need to write this part of the solution because when we have the frequency, when we have the amplitude, when we have the phase angle, we can directly, from these three information, we can directly write the signal. The amplitude is 169 cosine of omega, which is 120 pi t minus 45. So we can directly write the answer from these three information. We don't need to go through all these details. But for this example, I wrote these details to explain and make it clear that how we convert phasors to waveform signals, time domain signals. Okay. And now that we know what is phasor, what are some functions of the phasor? The first thing we can add and subtract signals using phasors. Let's see. Adding and subtracting phasors. If we have two or more phasors with the same angular frequency, we can simply add them. How we can add two phasors? We need to convert them to rectangular form and then add the real part and imaginary part. So here is the point. First, the phasors must have same angular frequency. If they do, then convert Phasor to rectangular form. 3. Add or subtract the real parts and imaginary parts. And 4, convert it back to polar mode. Okay, so let's see one example. We have two signals. V1 of t is equal to 10 cosine of 1000 t minus 45. V2 of t is equal to 5 cosine of 1000 t plus 30. We want to add these two signals. The first thing we should do, we should check the angular frequency. Are they the same or no? If they are not same, we cannot add them by Phasor adding and subtracting. So let's check the angular frequency. Both angular frequencies are same, 1000. So we can solve this problem with Phasor addition. So we say same omega, which is 1000. Okay, so the next step, we need to write the phasors. For V1 of t, the amplitude is 10, the angular frequency is negative 45. Okay, we convert it to rectangular form. It's 10 cosine of negative 45 plus j 10 sine of negative 45, which is equal to 7.07 minus j 7.07. So this one is the rectangular form of the phasor for V1. V2 of t. V2 of t is equal to the amplitude is 5, the phase angle is 30. So we convert it to rectangular form. So it's 5 cosine of 30 plus j sine of j 5 sine of 30, which is equal to 4.33 plus j 2.5. So this one was step 2 that we converted to step 2. Yeah, we converted them to polar. Now we add the real parts together and imaginary parts together. So we can say V3 is equal to V1 plus V2, which is equal to 7.07 plus 4.33 plus j negative 7.07 plus 2.5, which is equal to 11.4 minus J 4.57. Now we convert it back to polar. How we can convert it back to polar? We need to use some trigonometry equations. We know that if we have a number, let me change the color. If we have a number, a complex number, which is x plus jy, and we show it with r with the angle of theta, we know that x is r cosine of theta, y is r sine of theta, and of course we know r is equal to square root of x square plus y square, and theta is equal to arctangent of y over x. Okay, so these are some rules, and now we use this one to find r and this one to find theta. So x of course is 11.4 and y is negative 4.57. If we use these equations, we will have v3 is equal to 12.3 with the angle of negative 21.8. Or we can show it in this way, 12.3 e to the negative j 21.8. Okay, so at this point, I have the amplitude of V3, I have the phase angle of V3, and of course, because the original signals, they had the same frequency of 1000, the output signal also has the same frequency, which is 1000. So I can directly write the answer. I can say V3 is equal to 12.3 cosine of 1000 t minus 21.8. Okay, or I can just solve it in the detailed way, and we can say V3 of t is equal to the real part of 12.3 e to the power of negative j 21.8 e to the power of j 1000, which is equal to 12.3 cosine of 1000 t minus 21.8. So these two answers are exactly same. Okay, so we learned how to how to add or subtract two phasor signals. What about multiplication and division? If you remember, okay, first let me write the title. So multiplication and division of phasors. Okay, so if you remember, well, 10 minutes ago, I said that for addition, we write the phasors, convert them in rectangular form, and then add or subtract, then convert back them to polar mode. In fact, the multiplication and division is easier than subtraction and addition, because for multiplication and division, we don't need to do the second step and fourth step. Okay, we don't need to like convert them to rectangular form, and we can directly multiply or divide polar form of the signal. Okay, so let's see one example. So what steps are involved for multiplication and division of phasors? Part one, write the phasor in polar mode. Second, multiply or divide amplitude and add or subtract phase angles. And done. We need just to write the uh, time domain form of the signal. Let's see one example. We have these two signals. V1 of t is 10 cosine of 1000 t minus 45, and we have V2 of t, which is equal to 5 cosine of 1000 t plus 30. Okay, so we also, for multiplication and addition, we also need to do this step as well. We need to check to make sure that the phasors have the same angular frequency. If they don't, we cannot just multiply or divide them. So we can say before moving to for step one, we say check the angular frequencies and then write the phasors in the polar mode. Okay. So we want to multiply these two signals. In order to do that, we simply convert them to phasors. So we can say 10 cosine of, first of all, we check the frequencies. They both have the same frequency. So we write in the form of 10 e to the power of negative j 45. And this one is 5 e to the power of j 30. So V3 of t, which is equal to V1 of t times V2 of t, is equal to 10 with the angle of negative 45 times 5 with the angle of 30. If you remember, I said we multiply the amplitude. 10 times 5 is 50. And we add the phasors. So it's negative 45 and 30 is negative 50. And as a result, V3 of t will be equal to 50 cosine of 1000 t minus 15. So this one is the product of these two signals. Let's just divide those two signals. Let's say V4 of t is equal to V1 of t over V2 of t. So V1 of T of course is 10 with the angle of negative 45. V2 of T is 5 with the angle of 30, which is equal to 10 divided by 5 is 2. Negative 45 minus 30 is negative 75. So we can say V full of T is equal to 2 cosine of 1000 T minus 75 degrees. Also, 2 with the angle of negative 75 can be written in the form of 2e to the power of negative j 75. Okay, that was for this lecture. We learned about the phasors, how to convert a signal to, how to find the phasors of a signal, how to convert between rectangular and the polar format, what's the Euler's formula, and how to add, subtract, divide, and multiply the phasors, the signals using the phasors. Okay, see you in the next lecture.